So this is a little bit of an experimentation project I have going on. Have yet to see this. But it's another clutch. So it is huge as well. This right here is a twin disc clutch out of a supercharged Corvette, and it has these twin organic discs, so it looks like it's pretty clean. But what's interesting about it is that the first disc is actually built into the pressure plate, so I got this to kind of experiment with a little bit. After seeing it in the flesh, I'm not real confident I'm gonna be able to actually use it, unfortunately. But I find it to be a pretty interesting design nonetheless. So there you can see it gets rid of the typical floater plate that a twin disc has, and it actually integrates it into this pressure plate. So, you know, kind of my question here would be, is it possible to machine this floater down to where the entire assembly is thinner? And I'm not real sure. I'm not a clutch expert. I mean, I see rivets here. I don't know if this thing is meant to be disassembled or not. If that's possible, man, that would be awesome, because these are organic discs. They're sprung, and they should drive really nice. But they're also the correct diameter to go on a 302 flywheel. So if you look here, pretty much exactly the same. It's a tiny bit smaller outside diameter, but it does fit into the hub. No, it doesn't, actually. It does not fit into the hub. So we're running into the same issue as before, where this counter bore here is in the way of that. So I could probably use a 4-disc on this lower one, but how about this idea here? So it looks like the bolt holes are nowhere near lining up. So this might be a no-go, guys. I was really hoping to do something cool here with this clutch, but you know, maybe I might have somebody take a look at it, maybe send it off to South Bend and see if it's possible at all to use anything from here. But the overall height of it is just, it's huge, first of all. A lot of it, though, comes from this pressure plate with the built-in floater, which is really all I want to use. But it looks like I need a bigger flywheel if I'm gonna try that. This is probably something that would only work on the 164 tooth setup. So a little bit of a disappointment, but hey, you know, gotta take a few risks once in a while. I'm in the middle of upgrading my clutch and figured I would share a few things that I've got going on. I've mentioned before this 3.8 T5. Well, I've got a complete one right here with the starter. That's actually the same starter that's used with the 4R70W Explorer. So this is just a 99 to 04. I guess you could use the 96 to 97 if you need the mechanical speedometer. This one has an electric. And it fits the Ranger very well. They're light. I used one of these in the very beginning of my build, and it lasted about 3,000 miles before I was doing a third gear 10 PSI pull. The clutch held pretty well on that. This one's actually out of a Mustang GT. It's a little bit of a hybrid setup, but the clutch that I used before was just a 92 cast iron with the 50-ounce imbalance for the 302. So this one happens to be new, so this obviously isn't the exact one I ran, but I actually found the one I used out of the junkyard with the transmission. And speaking of the junkyard with the transmission, I found a spec clutch in the junkyard last year. So it looks to be a stage 3. All right, so we're at 278, 471. The last time I showed you guys this clutch, I made a video and it had 238 on it. So we've got 40,000. I've definitely slipped it under power. So overall, nothing too interesting. I did notice this clutch bearing right here broke the tabs off. I was really struggling to get this thing removed, and come to find out the tabs are broken. So I'll show you what I'm going to do with that. It spins okay. This is a Ford one right here. The part number on that is F7ZR7548AA. So that one's going in to replace it. If that breaks again, I might have to upgrade to something else. So basically I've got two different things going on here. One is this clutch that came out. So this is the 10.5 South Bend, and you can see it looks like it's got a little more burns on the pressure plate than it had before, but overall nothing too surprising. I'm going to get a measurement on this. The friction pads, the ceramics are pretty well worn, and the Kevlar ones are starting to chip away a little bit, but overall it held on the dyno, so I think it just needs a little more clamp load. This is the pressure plate that I ran with it. Not sure exactly what the deal is, but this is the one that I showed you earlier, and this is the spec pressure plate. The fingers have a little bit different design there, and I also noticed the way that the case is, the cover, it's a different kind of setup where it's shielded, so there's these springs under here. You can see this one's exposed, so I imagine that's probably some sort of SFI requirement to have that type of cover. So if anything, I expect, since this one's SFI approved and this one's not, that this is going to weigh more. So I'm going to get you guys a measurement on that. This is a Spec 3 and found it in the junkyard. A little dirty, but she cleaned up okay. 26 spline. So I have two options here. I could use that disc, well, I guess three options. I could use this disc with the pressure plate I had, which has certainly a higher clamp load than stock, or I could use the spec with the disc I had, or I could use the spec stage 3 as a complete kit. But I can tell you, I'm going to choose just the stiffer pedal at first and see if that gets us there. This is the Center Force stage 2, and it has a special kind of organic on the pressure plate versus the flywheel side. So I will be using my scale to give you guys some numbers here. We've got my clutch first. I believe it's about 2,600 pound clamp load. And then the Spec 3, I'm not sure about, or really the others. The results, the South Bend has the thinnest clutch disc at 0.25 inches, so should make it another, hopefully 30,000 miles, get us over 300K. The Center Force 2 is the thickest at 0.32 inches. You see these are the diameters, so what I run now is 10.5 inch. It occurred to me that before now I haven't shared a little secret about how I fixed the input shaft on my transmission. I didn't really fix it, but I'll show you what I did. So this is some very expensive grease that I've used for snowmobile crankshafts, and I am going to use that on the throwout bearing and the fulcrum ball, but more importantly, I'm going to replenish it under here. If you look at that pilot bearing, I don't know if I can get a good look at this. There we go. You'll notice that it's protruding out the end. So what I did was I put it in a press and pushed the rollers further onto the input shaft. So what that does is that gets the damaged part of the input shaft further in, so the bearing's riding on a new position. New surface that the bearing's riding on, so I got it away from this damaged spot. It also looks like the throwout bearing did not have enough grease on here, so I'm going to clean that up and use some of that same grease for there.
So as you can see, it's all back together and complete. And one thing I didn't mention was that I did reinforce this clutch bracket. I added 2 triangles to the back to keep it from flexing because it's a pretty thin piece of angle iron. I actually had to put some spacers between this plate and the transmission right behind there. So it actually ended up having to be spaced out about another 1/2 inch because the geometry of this blue spec pressure plate's different than what I had. But it drives really well, smooth engagement, and surprisingly the clutch is easier to push now. I'm not sure if this bracket was bending before potentially, but it's all good now. So that's it for this one. There will be another upgrade eventually, so until then, stay tuned for more.